My name is Scott Don with Harvest Midstream Operations, and today we're over here at Burns Terminal on our tank 308 to get some UT readings and let us know the condition of our tank. So traditionally what we've done, and we just done this a couple weeks ago, we'd have a group come in. They would either have to scaffold or come in here with the man lift. And if we have a man lift, a lot of times we have to come in here and mat the ground and put mats. And then the guys will go up and they UT it. If they do have, naturally if they have scaffolding, they have to move it as they go because they don't scaffold the whole thing. So it's pretty time consuming. I think what we've done here this morning would have taken them just a couple days after everything was set up. So this moves a lot faster, and hopefully it'll be a success.
From setup to finish, for them to do it the traditional way, how many days is involved between setup, taking readings, and tearing down and getting out the facility out the way?
Oh, that would be a week. You know, just the matting, to mat around this right here, that'd be about $5,000, $5 to $8,000, because you have to pay trucking fee to get the mats here and everything. You have to have equipment to put the mats out there.
Which is a crane.
So lot of stuff entailed by doing it the traditional way.
So let's say they come out, they spend the week, and then they give you a report. Are they telling you specifically where they went?
Yes, it'll be basically like they take a picture of it as they go, and they'll have the writing. So it's basically just a bunch of pictures they send you with the data and the report, correct?
Does it get hard in the field to remember where those things were, even with the photo reports?
Well, that's the problem. So in the past, they were taking these readings, and they wasn't taking them in the same spot. So that's one of the things I brought up with this company. So going forward, they was gonna start doing that, but up until that was brought up recently, it was never in the same spot. So you wasn't getting the data from the. Correct.
We want to continue servicing with a different way.
That sounds
by
good.
Using your drone to be able to do these things that they can do without having full scale crews.
Felix, how many different payloads does your team have?
Right now we've got 4 payloads. We've got that conventional ultrasonic we're working with right now. We've got that EMAT, electromagnetic acoustic transducer. Also same with the UT does wall thickness measurements, as both of them have limitations and advantages, so it's easy to switch in between. Then we got that diaphragm thickness DFT sensor that's used for coating thickness measurements. So if you actually not want to measure the wall thickness but the coating of it. Quite often used in for stuff going offshore, just to make sure, because you want to have a thick coating on there, because your salt water, salty air is gonna work on that coating. That is a couplant, basically a gel reading. So if you don't have anything here, you're not gonna get a good reading, because as soon as there's a small air gap, there's a rough surface, the signal is gonna reflect. So we have a pump on the drone, which basically just pumps. Let me just.
Does it pump on contact?
It. Pardon?
Does it pump on contact?
No, it has to pump basically just before contact, because the gel is coming out here, and you want to have the gel on top of the probe. So you pump before. Well, you have one platform, and we're focusing on the platform itself, and then you can mount different payloads onto the drone. So it's like a camera lens, same interface. You switch between payloads pretty easily, and you're good to go again. Taking off. Arming.
Gotcha.
Your standard DJI drone, basically, if you want to move forward, you pitch forward. If you want sideways, you roll. But this one here has a tiltable rotor design, so you can actually, I showed it earlier, I can do that again now in the next slide. You can actually position the drone like this, you can position the drone like this, because the orientation of the drone is decoupled from where it moves. Due to the tilt wing at PhD, they came up with this design because makes a lot more sense than a hexacopter. And once they figured that out, they said, like, hey, this is a great tool to do contact-based and stuff, inspections. And then we started off, let's look at NTD, start off with that. But that's why there's still so many capabilities. The drone is designed to do contact-based things. You can use it for visual inspection, but there's a DJI or there's other drones better than that, and we're not focusing on that. We're focusing on everything contact-based. So we actually even did a project for spot repair, that you take a tank where you have rusty spots, you grind off the surface with a grinding tool at the front, and then you use a spray and then coat it again. Wow. So there's like a big variety of opportunities you can do with this tool, everything contact-based. I can't measure the weld.
We'll let you measure the weld.
No, for weld inspection you would need a different sensor. You got it?
Yep.
And now we're here with contact-based inspections. And given that the technology is moving quite fast, we're going with basically a subscription-based model where we say our customers pay an annual fee for the equipment, but we actually take care of everything else. So all spare parts, training, all of that is included in the package. And on every year, once a year, we basically send you a new hardware. You return your old one once you receive the new one, and you get the newest hardware, the newest payloads, and the newest software. So instead of having a drone for 2 years and then having to reinvest because the next generation is out, we just roll it out to you. And
obsolete quick, you know. That's awesome.
I mean, I'm telling you, in 2 years' time, this is going to be old school already.